So we're going to be spending quite a bit of time talking about Extrema because there's a lot of really interesting calculus in this. It's going to lead us to also discussing um, kind of the epitome of working with derivatives, which is curve sketching, the idea of making a perfect graph by hand. But we're not anywhere close to ready for that yet. So I just want to take time to introduce the idea of Extrema here. So Extrema, oops, are the minimums and the maximums. You can also say extremes rather than extrema for the plural. Uh, minimum being the lows, maximums being the high. But we actually have two types of minimums and two types of maximums because there are two types of extrema. The first is what most people think of when they think of maximum and minimum, which is absolute extrema, or you'll sometimes see the word global extrema. These are the highest and lowest points for a function in its entire domain. Whereas relative or local extrema are the highest and lowest points for the function compared just to the points that are close by on either side. And the relative extrema is a bit confusing to explain here, so it's easiest with a picture. So here I have a graph of a function. I see that the absolute minimum is here at x equals 1, because that is the lowest point in the entire domain of this function. But there's another point here that looks like a minimum, but it's not the absolute minimum. Here at about negative a half. This is a relative minimum because it is the lowest point as long as I'm only looking close by. So if I'm only saying, well, I'm only looking at this part of the function, that's the minimum of the highlighted part. So that's the relative minimum. A lot of people like to think of relative minimums as being the minimums, things that look like minimums but aren't absolute. But technically speaking, even an absolute minimum is also a relative one, because even if I look just close by, it is the lowest point close by. Now, looking at this graph, I do not have any absolute maximums because on both ends, my graph is going up towards positive infinity. But I do see that something that looks like a maximum here at about x equals 0.2, and this would be a relative maximum because it's the highest point close by. The fact that there are higher points out here past 1 and past -1 doesn't impact this being the maximum close to this x value. Now, you're going to hear me using words a little bit differently here, and this is going to sound weird, but it's nice to have kind of a strategy, a foundation for when we say when, where, and what that's all referring to, especially with Extrema. If we're asking when a function is doing something, we're referring to an interval of x values. It could be over a domain, it could be from x, x is going from -3 to +7, but it's an interval. It may or may not include the endpoints. Where a function does something is a reference to the x value. And what a function is refers to the y value or the function value. So if I look at the graph here, this is a graph on a closed domain from -2 to 4. So, because I can see here, that's a closed endpoint. So my domain is from -2 to 4. And I'm asked, where is the absolute max? Where means that it's the x-coordinate. And I can see here is my absolute max, because that is the highest point in my entire domain. And where it is at 3.369. What the absolute max is the y-coordinate, 3.495. Then I'm asked for the absolute minimum. Well, the absolute minimum is over here because that's the lowest point in the entire domain. Where it is the x-coordinate, negative 1.273. What it is the y-coordinate, negative 9.013. Where are relative minimums? Well, relative minimums, technically, my absolute minimum is also a relative minimum because it's the lowest point close by. 1, 2 is not a relative minimum. That's actually a relative max. 2, 1.5 is a relative min. This is a relative max. But then I actually do have endpoints. My endpoints are extrema here because they are closed endpoints. 4, 0 is a relative minimum because it is lower than anything close to it. And negative 2, 1 is a relative maximum because it's higher than anything close to it. So where are my relative minimum are the x coordinates. I have one at x equals negative 1.273, and at x equals 2, and at x equals 4. Where are my relative maximums? I have one at x equals negative 2, x equals 1, x equals 3.369. So now kind of a little preview of how we're going to go about finding extrema using the same graph. Let's look at when is my function increasing and decreasing. When is referring to an interval. So when my function is increasing, it's from my absolute minimum, where my absolute minimum is, up to where my relative maximum at 1, 2 is. So this is from negative 1.273 to 1. This is the interval. So I could have also written it as negative 1.273 is less than x is less than 1. I can also see that I would have it increasing from 2 to 3.369. Or if I wrote it as an inequality, that's when my function's increasing. Well, then if I ask when is the slope of the function positive, if you notice, positive slopes are the same places where a function is increasing. So this is also true for when the slope is positive. And then when the function is decreasing, would be from negative 2 to negative 1.273, and from 1 to 2, whoops, and from 3.369 to 4. And that actually is also where my function is negative. But now if you notice, my extreme values are occurring here. My absolute minimum was when my function changed from decreasing to increasing, or a negative slope to a positive slope. Relative max at 1, function changed from increasing to decreasing, a positive slope to a negative slope. And if you notice, every single one of my extrema except the endpoints, my function is changing direction, or the slope is changing signs.